Okay, good afternoon, everyone. So this is just again a continuous lecture of what we had previous meeting. Okay, so I believe we stopped in the classification or classification of igneous rocks by using ternary diagram. So let me just switch to laser point. So I hope that you have already answered the activity as well as the assignment about the ternary diagram and some of the geochemical composition. So I hope kabalo na mo ani how to use the ternary diagram and how to plot the mineral model of balance. Okay, so in classifying igneous rocks, it's also important for you guys to know the different types of minerals that you can find in a hand sample or in thin section under the microscope. Okay, so when we say essential minerals, these are basically the primary minerals that are dominantly present in a rock. So their presence determines the root name given to the sample. So for example, this is a photomicrograph of a basalt. So you can see here a basalt consists primarily of plagioclase as well as clinopyroxene crystals. So we can see here large plagioclase, okay? And even this slender and long crystals, these are also plagioclase minerals, although mas gamay lang siya compared to this bigger. And the clinopyroxene here are basically the minerals that are the yellowish in or that has a yellow in color, kaning mga yellowish specks. So these are the clinopyroxene. So again, always remember its abbreviation, CPX for clinopyroxene and PLG for plagioclase. So this means that the absence of these primary or essential minerals would invalidate the name of the basalt. So dapat you have to also remember na ang basalt, it consists primarily of plagioclase. Okay, so when we say basalt, this is basically the volcanic rock that is consists mostly of plagioclase and clinopyroxene. But in the previous lecture that we had, 'di ba, if these minerals comprise the basalt as a volcanic rock, naapod siya equivalent. And its equivalent is what you call as, if you can still remember, we call it as gabbro. So si basalt, kung atoa siyang or kung slowly cooled siya throughout its process of formation, kung mahimo siyang intrusive, then it is gabbro. But because it is volcanic rock, so gitawag nato siya basalt. Okay, so the second mineral is what we have here, type minerals. So when we say type minerals, these minerals whose presence does not affect the root name but does allow a rock type to be subdivided by the use of qualifiers. Okay, so we have here an example, olivine gabbro. So kung maingon tag olivine gabbro, basically it is still a gabbro or it is still a gabbroic rock. So this again is an example of a photomicrograph of an olivine gabbro. And as you can see, dagan kaayong plagioclase, di ba? Because it comprises mostly of your gabbro as well as clinopyroxene. So if atong balikon sa fine-grained or sa volcanic rock, as you can see, these are very tiny crystals. And as naapod siya scale din eh. So you can still actually imagine unsa siya kagamay. So this is in terms of micron or micrometers. So 500 microns. Again, it's the same 500 microns, but as you can see, ang mga plagioclase, these are actually huge compared to what I've shown earlier. And what's also unique in this sample is because we have the presence of olivine. Okay, so this one. So si olivine is basically gitawag siya type mineral. So even if present siya sa gabbro, it does not affect the total composition of the group. It is still a gabbro. Pero because naa siya'y olivine, okay? Because naa siya'y olivine nga component, this one has something to do with the type of formation or the condition at which the gabbro has formed. And this one will be discussed in the advanced chapter. So again, pag may tag-type mineral, naa kay another mineral that is included in gabbro or in your in the rock, pero the presence of this type mineral will not alter the composition of gabbro. I mean, it is still a gabbro. It's just that naakay addition of other mineral such as olivine. Okay? Now we have what we call the accessory minerals. So pag accessory minerals, these are minerals that are present in few or minor amounts such as magnetite, apatite, chromite, or spinel. So in this photomicrograph, this is a Harshbergite sample, or when we say Harshbergite, it is a peridotite, type of peridotite or ultramafic rock, diba? And as you can see here, ang ihang accessory mineral is spinel, or represented by this abbreviation SP. So pag magnetite or apatite, it is usually found in volcanic rocks or even in mafic rocks such as gabbros or basalts. So here again, always remember the abbreviation. Pag olivine, OL, OPX, or orthopyroxene, and SP, spinel. So this means that since they only comprise minor amount in your sample, so they have a little to contribute to the rock nomenclature. And other type of mineral is what we have here, the post-magmatic mineral. So this mineral formed after complete crystallization of the magma. It means kaya siya sinabing post-magmatic because after the crystals or after the rock has formed, after its magmatic processes, no? So post siya, so that means it has something to do with the alteration, or it could be a hydrothermal mineral. So we have example here such as chlorite, epidote, and serpentine. So if I'm going to ask you, ang postmagmatic minerals, can it affect the chemical composition or the chemical composition of a rock? So a good answer for that is yes, it actually affects the chemical composition of your rock because it actually increases, for example, the volatile content of your sample. But unfortunately, even though maka-affect siya sa chemical composition sa bato, it is still not mura siya kanang gitawag na to, mura siya samok ni samok ra siya, iyarang gi messed up ang chemical composition sa imong rock because wala man siya originally na form sa magma. It is post-magmatic. So it does not represent the true composition of your magma. So kaya siya, it's not really that helpful if especially if ma-analyze ang mga post-magmatic minerals. So later, we will also discuss about how to get rid of these minerals or how to recalculate data when we say when we talk about the geochemical analysis later. Okay. So make sure that you're familiar with some of the processes under post-magmatic. So I can name a few here. We have serpentinization. So this is basically a sample or photomicrograph of a peridotite. Plagioclase peridotite because it has a plagioclase content. And I hope by now, kabalo na mo once maingon tag plagioclase peridotite, asa man siya na form. Is it shallow, deep, or intermediate? So I hope you can take a pause of this video and then kana answer on your own. Kay base mo gawa sa exam na. Anyway, so As you can see here, originally these are olivine, kaning mga colorful. So that's why um, siguro we're going to talk about some of the optical properties of these minerals, but siguro sa latter part na, ani nga course, because this is especially this is basically or this will be further discussed in advanced subjects such as optical mineralogy. But anyway, as you can see here, ang mga olivine, sila ang mga taas og interference color. So you call that interference color in optical properties. And since taas sila interference color, so these are basically the olivine, it surrounds the plagioclase. So inyong napansin ganina, if atong balikan tong fresh, this is a fresh peridotite or harshbergite. So mo ang mga olivine that is very less serpentinized. Wala kay siya serpentine. Siguro naa kaning mga nag-cut across the olivine. But as you can see here, kaning mga grayish or dark or grayish green na nag-cut across the olivine. So those are your serpentine. And this is, of course, formed by serpentinization. Okay, so now let's just review some of the diagrams used for classifying igneous rock. So this is the QAPF diagram. So this is according to the IUGS. So you have Q for quartz, A for alkali feldspar, P for plagioclase, and F for feldspathoid. So normally or usually when sa petrology, ang quartz o ang mga foids or feldspathoid don't really actually associate with each other, and it has something to do with their chemical composition. Kaya clear kaayo ani nga diagram nga in plotting the rocks or the rock sample, 'di ba, for example QAP, so wala kay foid or feldspathoid na component because they don't really coexist together in a magma. So if naay magma manggali, if you expect to crystallize quartz and foids or feldspathoid, so you would always think about there are two magma series na mo form sa quartz as well as sa feldspathoid. And of course, we will not discuss about that today, but I think that will be in the latter chapter na. Siguro chapter 5, 7, probably. Anyway, so yan. Kaya siya, it is well defined here nga ang quartz ug ang feldspathoid don't really coexist together in a magma. Okay, so I hope that is clear. And by using this classification of igneous rock, so this is or this can all be used, 'di ba? It's very obvious nga in for intrusive siya. You have granite, diorite, gabbro. So one of the problem that we can see here is that si diorite, the coexistence of diorite gabbro. So in order for you to differentiate these samples, you have to make sure nga kabalo ka sa plagioclase content or the anorthite content of the sample. So before I proceed with teaching you how to identify whether it's a diorite or gabbro, let us just first let me first introduce to you the so this is a ternary diagram of the feldspar. So we have here the alkali feldspar. So pag may alkali, it's from sodium to potassium. And here we have the plagioclase feldspar. So pag plagioclase feldspar, that is sodium to calcium. And in the Bowen's reaction series, gitudloan mo, 'di ba, nga ang continuous, for example, sa feldspar, we have the plagioclase feldspar, we have the abla OA. So basically, si abla OA represent this minerals here. So we have abla abla o so abla, so A for anorthite, this one, okay? B for bitonite, okay? L for labradorite, A for andesine, O for oligoclase, and A for albite. So, pag maingon ko nga anorthite content is 100, so it's written AN sub 100. So that is anorthite. So that means if we're going to check this ternary diagram, imo anorthite is basically 90 to 100, bitonite around 70 to 90, labradorite 50 to 70, and then andesine, oligoclase, or albite less than 50. So pag andesine, this would be siguro 30 to 50, and oligoclase 10 to 30, and albite 0 to 10 ang iyang anorthite content. So, again, sayon ra, diba? Because you always expect na tanang apex is, you expect that the apex would always be sum to 100 or would always account to 100%. So, 0 ang AN mo din eh, 0 to 10 because we are always with respect man siya sa anorthite content. So sa Bowen's reaction series, si diorite actually unsa man siya, mas late siya nga ma-crystallize compared with gabbro. So you would expect that gabbro has higher anorthite content. So it says here sa akong kodigo that gabbro has anorthite content of 50 or greater than 50, and diorite has less than 50 anorthite content. But if the anorthite content is not given, always expect that in gabbro, the plagioclase would be darker, okay? While for diorite, it's usually lighter plagioclase. Okay, so I hope this QAPF diagram now is, at least clear na siya when you are given distinction between diorite and gabbro. Okay. Next. So again, we're still with the intrusive rocks. So we also use this ternary diagram when identifying gabbroic rocks. So this is for This is for gabbroic rocks only. So pag gabbroic rocks only, you use plagioclase, pyroxene, and olivine. But actually, if mo try mo search online, there are actually some ternary nga dili lang mao ang components nila. We also have plagioclase, PLG, OPX, and CPX. So it actually depends, no? So depende na sa mineral or sa modal abundance na ihatag sa inyo ha. So for example, the dominant minerals are plagioclase, olivine, and pyroxene, then you use this diagram. If the olivine will not be given to you, then you either use this. And naapay isa, if amphibole is also given, then you choose the ternary that has an amphibole. So ingon ana lang. And it's again the same. I hope kabalo na mo ani unsa ang pagplot. So again, this is still 100. Here is 100, and as well as this apex here. Okay. For the peridotites, this is ternary diagram that we usually use. You're going to ask me, ma'am, why is that na siya marag distinction? So basically, these rocks here, they are classified as peridotites, okay? While kaning dinhi, lower or anything below lherzolite would be associated as pyroxenites. So dili lang mao ang ilahang So this is not also the case of of dividing between peridotites and pyroxenites. So when we say peridotites, basically they are what? They are upper mantle rocks. Okay? While pyroxenites naman, they represent crustal rocks. So you don't expect na you can find a lot of pyroxenites in the upper mantle. So usually they formed at the crustal level, while the peridotites, upper mantle rocks siya. Okay. And another IUGS diagram or the QAPF diagram for volcanic rocks naman. So just like what we encountered earlier about the diorite and basalt, for volcanic rocks, basically, naaputay andesite or basalt ang ato ang problem, or usually which poses or which the or the problem that we encounter is identifying between andesite and basalt. So always remember, for andesite and basalt, I will not give here the anorthite content, but we're going to talk about its color index or CI. So remember that the CI is on Samanshao with respect to the mafic mineral, or um, we always based it on the color of the mafic or ang kadaghanan sa imuhang mafic or dark minerals. So for example, if you are given an andesite, so dapat si andesite, unsa man siya? Is it high iyang color index or low? So dapat, since the andesite has lower mafic mineral, so you would expect lower iyang color index, so lower than 35%, and basalt would have higher than 35%. So just review about melanococratic, leucocratic, etc. And now for pyroclastics. So when we say this is the classification of the pyroclastic rocks. Yeah. So when we say pyroclastics, these are typically classified on the basis of the type of fragmental material. So type of fragmental material. O, mas paspas na ko mo sulat karon. And what are the fragmental materials? So we refer to the, for example, the fragmental materials we have unsa man. Mao ni ang ilahang fragmental material kanang naa sa edges. So pag lapilli, it is basically on the basis of its size 2 to 64 millimeters. Ash naman less than 2. Or the blocks and bumps would be or has greater than 64 millimeters. So always remember that when we say pyroclast, it does not need to be of volcanic origin. So there are also some maybe fragments of sedimentary or metamorphic country rock that is caught up in a violent eruption. Okay, so other than plotting the mineral modal abundance of a rock sample, so it's also important for us to know how we can devise a petrographic name of a certain sample. May either it's a volcanic, intermediate, or intrusive rock. Okay, so we have here the convention. So remember these three. And so we will go through with each of the convention later. So for example, you are given two samples basically different mineral composition. So naa kay olivine gabbro versus the muscovite biotite granite. And so, if I'm going to ask you, asa man dinhi ang ilahang type mineral. So, for example, sa gabbro, we know earlier that the type mineral is C. olivine because it does not actually change the petrographic name of the gabbro. It is still a gabbro. It's just that there is this one type mineral that is unique with your gabbro. And again, ang definite or ang complete interpretation with this will be discussed in the advanced chapters. So for granite naman, this is still a granite sample. It's just that unique siya because it contains another at least two type minerals. So we have here the muscovite and the biotite. Now for the convention, if we're going to focus our attention with the muscovite biotite granite, so if we're going to read the convention first, if several type minerals are listed in a rock name, the most abundant of them is listed as last or listed last. That means it is closest to the root name. By using the convention, we now have an idea that biotite is more abundant compared to muscovite in the granite sample. Okay, so since biotite is closest to the root name, which is granite. Number two, essential minerals cannot be distinguished as type minerals. Example, we have augite or augite basalt. So meaning, si augite basalt, dili siya pwede. There is no such thing as augite basalt. Why? Because an augite, what is an augite or an augite? It is an example of a clinopyroxene. And ganina, I've shown you earlier in the photomicrographs, both in basalt and in gabbro, na it consists mostly of pyroxene or clinopyroxene as well as plagioclase. And that's why it invalidates the petrographic name as augite or augite basalt. Pero if we're going to say olivine basalt, it is still okay, 'di ba? Because olivine is just a type mineral of the basalt. Third, textural qualifiers such as vesicular, poikilotic, etc. are placed before the root name. Kaya you might heard about the term porphyritic andesite. Andesite. So it's usual it comes before the root name andesite. Okay. Ayan, or porphyritic basalt. So we have the qualifier here, porphyritic, and the root name basalt. So I hope this one is also clear and you clearly understand how we devise the petrographic name of a sample. Okay, so as I have mentioned in our previous lecture, diba, there are methods that are being used in order to identify or classify different igneous rocks. So it includes, unsalan man, na atay gitawag na qualitative, quantitative, and chemical. So pag quality, or we usually do, or this is usually done during field works. So we identify the minerals and the textures that you can see in your hand sample or even in the field sa outcrop nga imuhang na-observe. Second would be the quantity by using the petrographic microscope or point counting. So you identify the minerals that you can find or that you can observe under the microscope. And lastly, we now have the chemical method or analysis. And that would be the last topic for this chapter. So the geochemical analysis. It allows us to know or to further constrain the composition of your rock sample. So the geochemical analysis, as you can see here, has three types of analysis. So we have bulk analysis, mineral chemistry, and spidergram or the trace element analysis. So again, under the geochemical analysis, these are the different types of analysis. We have whole rock analysis or bulk analysis. So this is done by subjecting any rock samples to chemical analysis. So other than subjecting rock samples, so this is basically you expect in powdered form. So i-crush pa na ang mga rock samples and then you turn it into fine sizes para naakay powdered form of the samples. Okay, so we also have here the major element composition of the minerals. So geochemical technique used to know the composition of a mineral. So you have to make sure na this is different with the whole rock because in whole rock, you are analyzing a whole, for example, I will give you 10 rocks. So tanang rocks, those 10 pieces of rocks, you're going to powder it and you analyze that. But for the major element composition, here I am going to give you one rock sample. And in one rock sample, for example, a peridotype. So unsa may mo i-analyze? So you analyze olivine, you analyze, let's say, a pyroxene, or an accessory mineral that is spinel. So tagsa-tagsa siya. It's per mineral, while ang whole rock is per rock. Okay, so so mo na ilang difference. Third, trace element analysis. So from the word trace element, so you measure the trace element compositions of either the mineral or a rock. So pwede siyang you measure the trace element sa rock mismo or sa powdered rock or sa individual mineral in the rock. So in this lesson, you will also be expected to learn, or I'm going to introduce you about the different types of elements. So when you say major elements, this is always expressed as an oxide. So it has greater than 1 weight percent. Minor element ranges from 0.1 to 1 weight percent, or basically less than 1 weight percent. So you have to make sure you have to remember the oxides here given, okay? So as you can see, kani mga major elements, sila pod ang mga major or the oxides that we usually see in the composition of each rocks, or for example, of each sample. For example, sa basalt. Basalt has at least 40% of silica. So meaning one of the major elements of basalt is the silica or SiO2. And pag trace element naman, it's usually less than 0.1 weight percent. And this is expressed as an element or in ppm or ppb. So pag ingon ana in ppm, so remember that, always remember when I say 1 weight percent, that is always equivalent to how much ppm. So you can pause the video and then answer or check your knowledge. So it's 10,000 ppm. Okay, I hope you got it right. Okay, so other than just giving you the values, basically napod siya significance or ilahang importance why we study different types of elements such as major, minor to trace. So pag maintang major elements, mostly we classify igneous rocks, and if we want to know the chemical evolution of melts and or crystal. So later, tudloan pud ta mo on how we determine the composition of the melt and with the crystal. Minor elements used to study the conditions under which the magmas form. And ang trace elements, although very few or very minimal ra kaayo sila ang ilang content sa imuhang sample, but they actually prove to be particularly effective as tracers. So we also call this as for trace elements, they are good petrogenetic indicators. So their presence of your sample actually gives you an idea sa ilahang condition kung asa sila na form, or gives you or helps you to constrain the origin of the magmas from which the rock has formed. Okay, so in geochemical analysis, we always have to make sure na we include accuracy and precision. So any measured value should be accompanied by a statement of accuracy and precision, indicating the reliability of the value of your data. Okay, so pag may precision, or their reproducibility, it is a number that indicates how much statistical variation from the average or mean value occurs in replicate determination. So, for example, I'm going to give you a precision of analysis for a basalt. Okay. And for example, we're going to look at its alumina or aluminum oxide sa basalt, ha? And its precision of analysis is plus minus 0.20 weight percent. Yan. So, for example, you have two samples, two basalt samples, A and B. So, si A, it has an average alumina content of, let's say, 13.65 weight percent. Given this is its precision of analysis, ha. But B has 13.90. So since dili sila exact or the same value, you would say nga, okay, probably different sila nga type of basalts or different na magma sila na formed. But because you are given this error plus minus 0.20 weight percent, that is basically if we're going to subtract 13.65, for example, or add 0.20. So, may na siyang 13.85, di ba? And for 13.90, if we're going to subtract 0.20, that will equal to 13.70%. So that means you can still say, or it is still possible that the two samples come from the same magma source, because it actually ranges ang ilahang composition from 13.7 to 13.85, which is very close to these, sorry, to these values, right? Ayan. So that's what we call the precision. Pag accuracy, it is less easily determined. It is an indication of how close the measurement is to the true value. And the true value here is usually it is compared with what we call a standard sample. So we will also, siguro not very detailed, but at least I will give you some example of the standard of the standard value that I'm talking about in the next lesson. Okay, next. Okay, so when we say geochemical analysis, it's not just analyzing the composition of minerals or the rocks. Basically, dapat nato siyang i-ansaman. The data, you need to plot it in something. So, unsa man tong something, you need to plot it in a diagram or in a figure. And that, in petrology, that diagram is known as, or collectively known as, the variation diagram. So in petrology and geo, you have here the three common types: the Cartesian graph of two variables, triangular diagram, and normalized diagram. So pag may Cartesian graph of two variables, the two variables is usually x and y coordinates, right? So pag x, this is what we call abscissa. If nakadungog mo na ko nga niyong abscissa, I am referring to the x-axis, and y is the coordinate. Okay, pag triangular diagram, this is not only used by the geochemical, but ganina, pag triangular, usually it's also same when we say ternary diagram. And for normalized diagrams, it is usually associated with normalization or another standard value. Nga dito nato i-normalized ang imuhang data. So this is an example when we say when we say Cartesian or bivariate plot. So by duha ka buok na kay x and y. So the y here is basically FeO and sodium oxide, while the abscissa is the silica. Okay. So if you want to plot, if you have a basalt, for example, not basalt, but given, let's say, andesite. So andesite has this silica content and as well as the iron is somewhere here. So ang ihang plot is din eh. So mo ni ang mga plots that I am talking about. Okay? So second, we have the ternary or the triangular diagram. Okay? So we have here the iron oxide, sodium, and silica. And lastly, this would be the normalized multi-element diagram. So ang imong gid siyang ginormalize, for example, we analyze a type of basalt. It is called an ocean island basalt. So in general, we call it basalt. And then we analyze it and plot. So not just plotting, but we also normalized it to the morb values. So si morb here is the normalizing value. Okay, so basically this is an REE diagram. So pag REE, although I will not discuss this here, but an example, so if increasing incompatibility, increasing incompatibility and increasing, this is increasing compatibility actually. Typo error na siya. So this is HREE versus, no, sorry. This is LREE, MREE, and then HREE. So that means your LREE is very incompatible or has high incompatibility compared to the MREE as well as the HREE. Okay, so quiz time. Again, using the table, identify the following. For example, major elements. Which do you think here are the major elements? Minor and trace. I'm going to give you, siguro, stop na ninyo ang video and then you try to answer if you can correctly answer this quiz. Okay, so pag maingon tag major elements, ay, sorry, wala din siya answer. Sige, so I will answer. Pag major elements, greater than 1 weight percent, right? So anything that is above 1, we have silica, titanium, etc. Except MnO, manganese oxide, it is less than 1. So this should be minor. So naay minor and major except trace. So wala kay trace nga makita diri. Am I correct? So wala, diba? Okay. In petrology, a good geochemical analysis of oxides in igneous rocks will normally lie between 100 or greater than 100. What do you think is the correct answer? So the correct answer here would be letter A. Joke, it's letter B. Okay. Trace element concentrations are usually expressed in parts per million by mass, and 1% is equal to how much ppm? So that is pila man? Is it 100? No, should be 10,000. Okay, so I hope sakto inyong answer. So if balihon nato, if you are given 0.1 weight percent, how much ppm is this? So, pila man ka ppm? So, kamo na mo answer, ana. That is, I think I will also include that in the quiz or in the exam rather. So bonus na siya. Okay, so it's also important for us to know unsa man tong mga instruments nga ginagamit for the geochemical analysis, 'di ba? So again, for the whole rock, what is another term for whole rock? We have, it's called bulk. Okay? Bulk siya. Bulk rock because it's everything. Tanang bato ang i-analyze. Dili lang siya mopili kang mineral. So it's called bulk analysis or whole rock analysis. So a good example, we have X-ray fluorescence spectrometer or XRF. So used to analyze crushed and powdered rock samples to get their chemical composition. So the most commonly used diagram for volcanics is what we have here, the task diagram. So I believe this is part of your activity. I hope nag-enjoy ra mo nga gaplat ani. So pag maingon tag task, it is just very obvious, 'di ba? Here you have an alkalite. This is total alkali with silica. So unsay pasabot sa alkali? Asa man diri ang alkali? So again, this is still a by type of a it is a variation diagram that is bivariate plot, 'di ba? You have x and y. So this is your alkali. So pag may kang alkali, it is sodium and potassium. And silica naman is this. So pag SiO2, it's either silicon dioxide or silica. Muna siya ang iyahang other or the other term. Pag aluminum oxide, that is alumina. And there are other terms. So I think it's mentioned in winter. If not, I am not sure asa nako to siya na nabasahan. Winter or ni best. I'm not sure. So just double check. Okay, so when we say task diagram, it basically divides the volcanic rocks into two series. We have alkali series and subalkali series. So this also means nga you have two magma sources. So we have two magma sources. We have an alkali rich and a subalkali enriched magma. So that means nga kaning mga plots nimo din that lie within the subalkali series are or can be named as subalkali basalt, basaltic andesite, andesite to rhyolite. While for the alkali series, wala kay phonolite din sa imong subalkali, 'di ba? But it's only phonolite, it's only present if you have a very or if your samples are alkalic rich. You have your phonolite and other basalt pod but dili siya subalkali basalt but alkali basalt. Okay? So unsa may ma'am unsa may importance what information can we get here? So the information you can get here daghan siya actually. It's not just the different types of basalts but also the basalts that you know that are formed along mid-oceanic ridges or sa mga subduction zones. And that we are not going to talk about that here but siguro sa mga advanced chapters na gihapon kay yeah, there are still concepts na kailangan akong i-introduce ninyo before we jump into those topics. What else do I want to say here? Yeah, and for subalkali, it is also divided into two. You have tholeiitic and alkaline. So these are the magma series. Tawag na siya og magma series. And now if you're going to ask me nganong if why do you think, ma'am, na if i-analyze ang volcanic rocks, we can get the magma composition? So always remember that the magma or that your volcanic rocks, since they are very fine, so pag fine siya, 'di ba? Dili siya slow cooling. It represent basically the melt composition of your magma. So if you can still remember the diagram I've shown last meeting. So naakay mga crystals, right? And basically kaning imong mga fine grained, this represents your melt composition. And so if we analyze a volcanic rock or volcanic rocks, that means we are getting the composition of the magma from which it formed. And that's why if going back to this slide, I have mentioned here the magma series, and that includes the alkali and subalkali. And if you're going to divide subalkali, napatay another magma series, tholeiitic and calc alkalide. So this is important, guys, because imuhang basalts or the volcanic rocks formed along mid-oceanic ridges will have different or distinct geochemical signature to those rocks that will form um, along the subduction zones or sa imuhang mga sa mga subduction zones or that will gradually produce as the island arcs. So lahi siya og um, signature, and that is why it is important for us to know at least the basic. So this is very basic when it comes to the geochemical composition of the different igneous rocks. Okay, so in volcanic rocks, it's also important for you to understand that that using the TAS or the task diagram, it is important for us to ensure that they have recalculated in volatile free form to eliminate the possible distorting processes due to alteration or weathering. Okay, and in order for us to get a volatile free form of the sample or of the analysis, so we get the LOI. So what again is LOI? The loss on ignition. Loss on ignition. So loss on ignition, it means that you monitor the alteration of your sample. So again, dili ta ganahan nga very altered or very weathered ang ato ang samples because it affects the composition of of your samples. So pag maapektuhan ang composition, it is not actually the representative, no, that not the actual composition of your sample, but rather the post-magmatic processes. Kasi pag sinabing alteration and weathering, those are post-magmatic hydrothermal processes, and we don't want that in our sample. And that's why we apply or we use loss on ignition. So how do we use loss on ignition? So it's either sa mga technologies karon or the instruments, what we're going to do here is we heat the samples to 1000 degrees Celsius. Imong i-heat ang imong sample so that it will eliminate the volatile content in the sample, such as, for example, if na H2O or CO2 contents, and we don't want that. Okay, and other than that, we also have a chemical formula, or it's not a chemical formula, but you just get the factor. So we have here the total analysis over the, let me just copy first, for example, for a while, guys. Okay, here. So we have an analysis of a basalt here. So in order to get its LOI, so total analysis over, let's say this is TA. This is TA minus the volatiles in percent or weight percent. in order to get the factor. Okay, so for example, given this table, you expect that the total analysis is 100.1. So 100.1 over, so 100.1 minus, so you just add up. Asa man ang mga volatiles nimo din eh. So basically, I'm not going to point it out here. I hope you know how to identify the volatile. So it is around 1.9, and 100.1 over 98.2 gives you 1.02. So that's the factor. And what are you going to do with 1.02? So you multiply that to 1.02, 1.02, and basically you will end up 100.1. So that means you still get the total analysis, but ang nawala is the volatile content. So that's why we have to use this, or we have to recalculate. So this is how to recalculate the analysis, or in order to get rid of the volatile content. So we call that as LOI. Okay. And other than the use of XRF for whole rock analysis or bulk analysis, we also have here EPMA. So ang EPMA naman is more on the application sa mineral chemistry. So again, pag mineral chemistry, we analyze the major or the element composition of your minerals other than the rock. And this is an example of a diagram. So this is also a bivariate diagram. I will not explain this here in details, but I think we're going to have a presentation of article review. So basically, makabalo ra po niya mo ani. Trace element analysis, a good example or an instrument that is used here is the LAICPMS, or the laser ablation inductively coupled plasma mass spectrometry. Okay, so it analyzes trace element composition of a mineral or a rock. So here we can see another, so this is not an REE but a spider gram. So if normalized gali siya guys, normalized siya because you can see it is normalized to chondrite. So pag normalized siya, this is what type of variation diagram? This is a normalized multi-element diagram. Okay, and since we're also talking about the chemical composition, it's also important for you to know that when you say acidic, it is referring to silica content that is greater than 66 and so on. Okay, so it's also important for us to know that when we say felsic and mafic, it is based on mineralogy. And pag acidic and basic naman, it refers to the magmas. And pag magmas, we always think about the silica content. Or if wata kabalo sa silica content, usually sa color sa samples. And last question, is the silica content of a rock similar to the quartz content? Yes or no? So what is the chemical formula of quartz? It's still SiO2. But is it the same or not? So I hope your answer is no. Dili siya the same. Okay, so this will be the end of my presentation, and I will see you in the next lecture. Thank you.